Alright, you guys see my screen?
Yeah.
Alright, okay, so it is 9 o'clock. Anybody else got their phone out? Got to be 9 straight up. Yeah, no, hello? Anybody? You? Yeah? Alrighty, so it is 5-1 today. This is Chem 1110 Cumulative Review Day 3. Alrighty, so this is what I got. So this is the front side of my 3x5, and this is the back side of my 3x5. Yeah, so we're just gonna continue right along here and see what happens. I will say I get more and more disappointed every day. Not as much in you guys, although I think today is bad. My math class was missing 40 kids today. Yeah. I was below 50% attendance for my first time this year. Although I think right now we're way below that, aren't we? Anybody see a number?
40.
Yeah, which means we're missing 74 kids. Now, I'm not sure if you guys remember or not, but does anyone know what percent of your grade this test is?
20.
Yeah, this is 20% of your grade. Okay, I need y'all to think about that for just a second. The final is 20% of your grade. That to me is astronomically high. And that was going to be one of the things I discussed in our meeting we had this year, but they canceled that meeting the night before the meeting because of all this coronavirus stuff. But yeah, you think about that. 20% of your grade is this test, which is why I wanted to make sure we had plenty of time to go over it. When I'm missing 74 kids, I don't know. See how that might be a problem? Yeah. Alrighty, so what we're going to do is we're just going to do the same thing we did last time. Going to spend the next however long it takes to go through my note card. And the more I look at it, we're gonna finish pretty much next time as far as covering each topic that's on the test. So what I was thinking is next Wednesday we would have like a Q&A where I would ask you to go back through all the cumulative review notes, and any topic that's on there that you don't 100% understand, I would address again. That sound like a good idea?
Yeah.
Okay. Alright, so today, this is my first thing I have written down, and it says, what creates a high melting point in a hydrocarbon? Okay. Now, we did this, okay, and there are a couple of things that I can look for to determine. Let's say they gave me 4 things, okay, and I wanted to differentiate which one of those 4 items is going to have the highest, and let's say, melting point, okay. Does anybody know what any of those things are? What one of those could be?
Has the most carbon.
Okay, so the highest number of C's. That's an easy thing to look for, right? Just count up how many C's are there. Okay, that's one of them. What's another thing?
Like lower surface area.
So lower number of branches?
Okay, so you two...
It's the opposite.
Okay, so you guys just...
Number of branches.
Say that again.
Like more branches.
More branches creates a higher melting point?
Well, I thought less branches created a higher melting point.
Exactly. Less branches. Now...
That's what I said the first time.
Well, but one of you said it backwards. Because I had a boy and a girl and you said opposite things, didn't they?
No, we said the same thing.
You sure about that?
I don't know.
Okay. Now, what does less branches really give me?
Higher surface area.
Yes, so more surface area. More surface area does that. Okay? And then there's one other thing that will give me a higher melting point. Anybody know what it is?
Is there anything besides the C and an H?
That changes it differently, but you're right. So that's not going to be part of this question. But that is a good point, Sierra, but that is not part of this question. These will all just be C's and H's. Do you see what I'm saying there?
Yeah.
Okay, there's one more.
Fewest number of double and triple bonds.
Exactly. Fewest number of... Can we just go multiple and cover them? Does anybody know what else, how else I could say this? Besides being the fewest number of multiple bonds? Anybody know another word for this? It is the most something. Starts with an S.
Single bonds?
Nope. Nobody? Didn't we talk about being saturated in here? It's the most saturated, which means that holds the most H's. And this goes back to when you're talking about saturated what? Nobody knows what it... Yeah, saturated fats, right? Saturated fats are what at room temperature? Does anybody know?
They're liquid.
No. Saturated fats are solids at room temperature. Okay? Unsaturated fats are good fats. That's why they're liquids at room temperature. Okay? So these are things that can give something a higher melting point. So what it does, it gives you 4 items. And it says, which one of these is going to have the highest melting point? Right? Well, I'm going to look for the highest number of C's. Well, if they have the same number of C's, then I will look for less branches. If they have the same number of branches, then I will look for the fewest number of multiple bonds. Does that make sense?
Yeah.
Alrighty. So, from there, I want to do this because I've not been very good at covering this. 3-ethyl 4-octene. Okay? Now, what I want to do, well, what do you think we're going to try and do here?
Draw it.
Draw it, right? So how would I draw that?
You would start with the octene backbone.
Okay, so how many lines is that?
7.
Like that?
One more.
Like that. Okay, so there's my octane. Well, that's my octane. I got to make it 3-ethyl-4-octane. So what do I do now?
Double bond.
Double bond where?
At 4.
So I go 1, 2, 3, so 4. I'm going to put a double bond right there. Now that's my 4-octane, right? Then what?
Put an ethyl on 3.
Go to 3, 1, 2, 3, and put an ethyl. What's an ethyl?
2 line.
Would that be 3-ethyl-4-octane?
Pretty sure.
Pretty sure. Now, that's one way. Okay? How else could I do that?
With one being on the rightmost carbon.
Okay, I could, but I mean, this is the what form? That's the skeleton form, right? How else might they want me to write that?
Condensed form.
Condensed form, right? I mean, think of a way I would write that condensed. Nobody?
You'd start with CH3CH2C.
CH3CH2. Then I would have C right there. So that gets me that one. So that's 1, 2. So that's 1, 2. That works. You're telling me that's my 3.
Need CH.
I need a CH. How would I signify this? I need that.
One above it.
Okay, so I'm out of room there. Can I do this and just go CH2, CH3? Would that signify that as well?
Yes.
Okay, so that gets me to there. What about here?
Could be a CH.
I'd go CH, and that's my 4. Okay, and then what about there?
Another
CH.
CH.
Another CH. Okay, that's my 5, and I need 6 and 7. What would be 6 and 7? What?
CH2.
CH2, CH2, and then a
CH3.
CH3 like that. And that would give me 5, 6, 7, and 8. Yeah, that'd work. Is there another... Go ahead.
Is there any way to signify that there's a double bond? Like, do you have to...
Now, this is just something you kind of have to know. Now, sometimes, this is what I was going to say, there are literally a couple of other ways I could have done this. Okay? So, was that you, Butler? Who was that?
Yeah, that's all.
Yeah. So, another way you could have done this, and it just kind of depends, is they would have done this. They would have went CH3, CH2, CH, right? And then they would have went CH double bond CH. And then here, because they're the same, they could have went CH2 taken twice and then a CH3. And then have gone and branched that as a CH2, CH3. Yeah, I would say you could have done that as well. To me, these are the same, just done a little differently. You know what I'm saying? The key is just being able to look at this and see what it's telling me. This is telling me that, which is telling me that. So it's just one of those things. I don't know. I don't know that there's... You know, as I look at the test, I look at this question, I see you need to go from here to here, because that, to me, is what makes it the easiest. So what I would do if I was doing this, I would take the 4 they give me, and I would draw it like this, and then look at it. Does that make sense?
Yeah.
Yeah, that's how I would answer that. Okay? And along those lines, there are a couple of the valid name questions. You guys remember the valid name type questions that I'm talking about? We've had them on the last couple of tests. Who knows what I'm talking about?
Yeah.
Where they give you like 4 names and they see which one of these is valid, and the other ones like they've numbered from the wrong end or something. So there are 2 to 3 of these as far as that goes. Just which of the following is a valid name? And again, I would write the name out and I would draw it and just look at it. And most of the time you can just see, hey, they should have counted from the other end. I'm going to get better numbers. Do you know what I'm saying? Just things like that. There's really no way to go over that unless I just do like 7 of them. So maybe that Wednesday, that might be something somebody says, hey, let's go, you know what I mean? Okay? Next thing I've written down is this. I've written down aromatic does not equal cyclo. Who knows what that means?
I mean, if you have a benzene ring, you don't have to write cyclo before the part of the backbone.
That's part of it. Part of it.
Cyclo doesn't have to have the alternating double bond.
Exactly. Okay, so make sure you understand that to be an aromatic, it must look like this. It has to have that. Cyclo is just any other combination. So could I have that in a cyclical structure?
Yes.
Yes. Okay, that is not a benzene ring. To be a benzene ring, the double bonds must do what? They must alternate. If they don't do this, it is not an aromatic. This is a cyclical structure, but it is not aromatic. Does that make sense? Okay. Now, something we just covered, and I want to say in this chapter that they already throw on the test are those 4, 5, 4, I don't know. I don't remember. But they throw these on there. They throw on hydrogenation. What else? We did 4 or 5 of these. We did hydrogenation, then what did we do? Anybody remember?
Hydration.
We did hydration was one of them. What else?
Halogenation.
We did halogenation. Hydrohalogenation. Was that it? Just the 4 of those? I think that's it, right?
Yeah.
Okay, now, 2 of those require a what?
Catalyst.
Catalyst. What were they?
Wasn't PD.
Okay, but you're right, but which ones were they? Halogenation required palladium?
I don't know.
I'm asking you. Nobody remembers?
Hydrogenation.
Hydrogenation required PD. What else?
Hydration required H2SO4.
Hydration required H2SO4. Now there was one that is not on here that was similar to this, which is why I said 5 earlier. Anybody remember the one that caused us a little grief?
Was it like the sulfur or nitrogen one?
No,
That was on the homework?
no, but it was on the homework, but that wasn't it.
CO2?
Yes, it was, but what was the CO2 with? Do you remember?
Amy Bowden?
You're right, but there was one caveat there that worked there. Anybody remember what it was?
Was it the FeCl3?
You're right, but there was, but there was one other thing that changed with it. You're both on the same track. Anybody remember?
One of the Cl bonds to the ring, and then one of them bonds to the H that leads.
You're right again, but there's still something you're missing. That only applied in one specific case. Anybody remember what it was? Nobody? Because this is different. The Cl2 one must be a benzene. That only applied when it was benzene plus CO2 and FeCl3. This is the one. It only applied when it was benzene. If it's just regular halogenation, it's different. This one was with CO2 and Br2, right? Here, Br2 doesn't work. But if I had a benzene and I added CO2 to it, I always got this out. Okay? If I have benzene and CO2, okay, I want to say that was Hudman, right? I end up with this plus that. That right there. That's halogenation of a benzene. That is different than if it's just regular halogenation of another alkene. You see what I'm talking about? Do you see the difference there? If it was just this, let's say I had this. I had that plus CO2. That is going to give me this. These are different because that is not what?
Benzene ring.
That's not a benzene ring. This only applies if I'm taking benzene and adding chlorine to it. This is any other double bond plus CO2 is going to get what's called di-substitute. It means they're both going to go on that double bond, or where that double bond was. Here, I'm going to take, that Cl is going to replace one of my H's. That H is going to bond to that chlorine. That Cl is going to bond to that benzene, which I believe is what you said, wasn't it, Hudman?
Yep.
Okay? So just make sure we understand the difference there. Okay? Okay. So this is so here we go. So if I take something, let's say I've got a blank there, and I add HBr to it, and I get out this. Okay, watch. And I get out this. Can anybody tell me what I started with to get that out?
Wouldn't it be a cyclopentane with an ethyl on it, with a double bond?
So you're saying I'm going to start with a cyclopentane, so I have my cyclopentane. Okay, and then what happened?
Then there would be a double bond.
Double bond right here.
Yeah.
And
you have your ethyl.
like that.
Yeah.
So if I take, so you're telling me if I take this and I add HBr to this, I'm going to get that?
Yes.
Who am I talking to?
Savannah.
Who?
Savannah Clark.
Okay, so Savannah. So why do you say this?
Because the double bond would break and the H would go to the bottom one because that one has more H's. And then the Br would go to the other one.
Damn. That's a good job. That's exactly right. Exactly right. Now, my next question is why does it do that? Anybody remember?
Because of the Markov rule, the H goes to the bottom one.
Markovnikov's rule. Okay? Now, someone else, Sierra and Savannah are out. What one of the four that we just talked about is that an example of?
Hydrohalogenation.
Yep, that's hydrohalogenation. And it was usually HBr, or what was the other one they usually used? HCl. They were the two we saw the most. That makes sense? Now, here's my next question. If I have a compound that gains an OH somewhere, what must have been added to it? Okay? So I'm not sure if this question makes sense, but I'm trying to word it in a way that will lead you to understand this. Let's say I take something, a blank, right? And I add something to that, and I get this bonded to an OH. This gains an OH. Do you understand what I'm asking there? If I have a compound that contains an OH, or that gains an OH, what must have been added to it? Meaning, here's my compound, I add something to it, and it gains an OH. Does anybody know what's going to go in that blank right there?
H2O.
H2O. What else?
H2SO4
And
is a catalyst.
H2SO4 is a catalyst. What would this be an example of?
Hydration.
Hydration. Right? Hydration. And what would that make my new compound? Anybody remember?
An alcohol.
It'd make it an alcohol. Okay?
Or a phenol.
Now, great point. It would make it a phenol if what I had started with was a what?
Benzene ring.
Benzene ring, exactly. Okay? Good job. Alrighty. Now, one thing I know that there's one or two questions on, and that is a polymer to a monomer and vice versa. Meaning, they're going to give you a polymer and expect you to determine what monomer generated that. Remember how I showed you to just take it out and draw the breaks and decide what that monomer was? But then I've also written vice versa, so they must ask you two of these. And one is they give you a monomer and say, what polymer does that generate? Well, what do I do? How do I go from a monomer to a polymer? Anybody remember?
Just repeat it.
Yeah, just break that double bond and write it again. Write it again and write it again and write it again. I don't know. I think these should be pretty easy. As far as I looked at the test, the questions they asked, I felt were easy. Does that make sense? Just know that a monomer is always going to contain a what? It will have what in it? Anybody know?
A double bond?
Yeah, it's going to have a double bond in it somewhere. The polymer will probably not have a double bond because that's what breaks to create it. Does that make sense?
Could a polymer have a double bond? Like a
It-
double bond?
It could, but I don't think they'll muddy the water that way. You know what I'm saying? Like, I mean, they could make it like an aldehyde or something, but understand that it's going to have a carbon-carbon double bond in it. That's what's going to break. Like, if it was an aldehyde that had like double bonded to an O, that's not going to polymerize. The polymerization happens from the carbon-carbon double bond breaking. So I don't think they would muddy the water that way. Was that you, Allison?
Yeah.
So I don't think they'll do that. Okay? Alrighty, now, I'm not sure. I'm kind of going out on a limb here. I'm not sure if we will understand what this question asks. But if I said O, M, and P, well, that's supposed to be R, and I wrote R examples of, and I wrote blank blank. Anybody here fill in that blank, those two blanks? Doesn't matter what it is. If I said I had ortho, meta, or para anything, could you tell me what they would be examples of?
Benzene ring?
You're right, they're going to be a benzene ring, but they are examples of a very specific thing we've talked about. Let's say I did this.
Disubstituted?
Ooh, damn. You're right, but that's only one word.
Benzene, disubstitute benzene?
Nope. But that would work as well, which makes me question my. So let's say I had this. I've got this, and I have this. They're my three. So O, M, and P, right? Ortho, meta, para. These are all examples of something very specific.
Hydroxyl groups?
No, but damn, all those technically work. Let me think. So now I got to think of a different way to answer this question. None of them came to mind when I wrote this down.
Constitutional isomers?
Who said that? Was that you, Weston?
Weston.
Nice. They are all examples of. So, how did you get there?
Well, they're all like built the same. They're just the branches are on different
Exactly.
carbons, so they're just arranged different.
Exactly, which means they would all have the exact same what?
Formula?
They'd have the exact same formula, but they are bonded together differently. Exactly. Whew, glad we finally got there. But does that make sense? How that works here? Something I know they asked, didn't they ask 4 questions on the last test that had to do with that? Constitutional isomers. Anybody remember that?
Yeah.
Okay. So, I don't know. There's a question about that, and I tried to word that in a way. I did not think we would come up with 3 other potential 3 other potential answers that were all 2 words, but that's it. Okay? And that, I don't know. All I wrote down was a number, so I'm going to have to go and look at that. Oh. Alright. So, there is a question on the test which I believe they had the wrong answer to. But we've already fixed that, so I think we're good to go, and I've already addressed that question. And then all I've written down is halogenation. We already talked about halogenation, didn't we? Didn't we already talk about this? Yeah. Hudman. Didn't we talk about the 2 examples of halogenation already? Hudman here? No Hudman? What number are we at?
Yeah, I'm here. Sorry.
Wasn't it you that we talked about the 2 examples of halogenation?
Yeah.
Yeah, so I guess I would say just remember there are 2 types of this, right? One is if it's just a regular double bond, and then the other one is if it's a benzene ring. Correct? And that's basically that question right there. Well, so we already talked about that. Alrighty. That gets us up through question 65. So next time will be questions 66 through 80 next time. And then after that, I'm going to be honest, I really like the idea of you guys being able to go through, because that will cover all 80 questions. Okay? So next Wednesday, and I mean maybe if you got some time this weekend, you get started on it. I would like you to go through every type of question I've discussed, and then at your discretion, I will just open it up and I will just highlight whatever it is you think we need to work on. Does that sound like a plan to anybody besides me?
Sounds great.
Okay, what number are we at?
50.
50.
Wow. So that means we are missing.
Sounds like 54.
I got up to 54. Okay, well technically 2 of them are me, because I'm in and presenting, so I count as 2. So that would give me 114 minus 52, 62 divide. That means we are missing 54.4% of my students. That hurts my heart. Wow. I'm going to call you guys to repentance. Alrighty. Any questions for me right now?
Nope.
Anybody know what Monday is?
May 4th.
Is it your birthday?
No.
Star Wars Day.
Star Wars Day! Who was that?
Tiernan.
Who?
Tiernan.
Denton! That's right! We got a kindred spirit, Star Wars Day. Yeah, may the 4th be with you. Okay?
Yeah, last episode of Clone Wars comes out.
I haven't seen that yet, but one of my students in my math class was extolling me to watch it. But I was also told that the new Star Wars comes out on Disney Plus that day.
Yeah.
Yeah, Rise of Skywalker just on
Yeah.
Disney Plus.
So we know what I'll be doing Monday afternoon. Yeah. I'm a Star Wars guy. I was a kid when it came out, the original. You'd have to understand how big that was. But you'd have to go back in time to like 1986 or something. 7 maybe, I don't know, 88. When did Star Wars came out? No, I meant...
The first one was in 77.
70, I meant, yeah, not 70. 77, yeah, 1977. Wow, damn.
Yeah.
Hey, oh. Dude, that's like 2 strikes already. I see how it is. I'll remember that. Well, alrighty. I'm going to leave this on for about a half an hour. I irrigate today, so I got to go. Mason got his wisdom teeth out, so you go check on him. I'm going to leave it on for about a half an hour. If you need anything, chime in, okay?
Okay, thanks.
Okay, see you guys. Have a good weekend.
Mr. Denton.
Yo!
So we haven't been reviewing a lot of the math we did this year. Is there not gonna be a lot of math on this?